Assalamu alaikum. Welcome to our presentation. The title of our presentation is High Performance Antenna System based on machine learning technique for mid-band 5G applications. So our team is Mohammad Ashraful Haq, Dr. Selim Al-Bauri, MD Abdul Rahman and Ridwan Al-Mahmoud. So these are the table of the contents, and finally the introduction, how the machine learning can improve the accuracy of the 5G application, especially in the N70 end-to-end. And in this verse, how the simulation, measurement and RLC equivalent circuit can be correlated in the one design. So the methodology has been used, how the data can be exported from the CST. The very first at the beginning, design an antenna in the CST, then export data by using the parametric sweep and prepare data set for the machine learning analysis. So how to export data set from the CST, it has been discussed in the previous slide. The machine learning methodology can be coming in the next slide, how they apply to the machine learning methods. Actually we are using the trained data for the 80% and the tested data for the 20%, and then evaluate by using the data set using the machine learning models. So there are many machine learning models such as linear regression, random forest regression, XGB regression and the Gaussian process regression. So by using these regression models, we have to evaluate and finally check that which one is best for this accuracy in this antenna design. And actually these are the tables for the validation of the antenna results with the machine learning, because we predict the two things. First one is for frequency and second one for the gain. So this one is the table for the frequency prediction. Here we can find the MAE, MAC, RMAC. So these are the all of the errors, like MAE is the mean absolute error. So the error is percentage is lower, that time, that means it is very good. And finally the two parameters R square and the variance score is the performance evaluator. That means the R square and variance score is much higher, is the best results. So in this regards, the gain prediction, we also get the same things. So we got some errors and also the R square, variance score, and comparing with these tables, we got the best results, which a regression model will be this fit for this regression. So according to this analysis, we got this simulated frequency versus predicted frequency, the left figure, and the right figure is for the simulated gain versus the predicted gain. So for the frequency prediction, linear regression is the best results, and for the gain prediction, Gaussian regression process is the best results. And finally, this is our proposed design for the Yagi antenna, and on the right side, how we can measure this antenna in the lab, and our simulated results and the prediction results almost similar. The reflection coefficient is also similar to the predicted results and the simulated results, and also the gain and efficiency is also good according to the simulated and the measured results. So both of the results simulated versus measured is also very good in terms of this calculation in terms of our antenna. And finally, we also evaluate the RLC equivalent circuit. The left side figure is the RLC equivalent circuit, which are our Yagi antenna. And finally, we got the RLC lumped element, and finally also validate the results with our CST simulation software. And alhamdulillah, the result is also similar, and the resonant frequency also in the 3.5 gigahertz, which is suited for the N70 8.5G frequency. And the key features of this antenna is the 5G N78 band. It has a high gain, high efficiency, we have already seen, and the similarity in the equivalent circuit verified with the machine learning models, and very simple construction directional antenna, and we are using very low cost effort for material, and the size also very compact as we are using the Aguda antenna. So if we are thinking about the commercialization, then it will be very good candidate on this antenna because of these key features, and also it will be work as a 5G base station, and also the transportation and the autonomous vehicles, and also the smart city infrastructures and the surveillance and the security. Because of using this antenna, we have been correlate all of the things at a time, and which has been shown in these previous slides, that been validated using machine learnings, using RLC equivalent circuit, using measurement versus simulated. So all of the things have been validated. So according to this, we can say that we can commercialize it's very good. So this is the conclusion. So I think it's okay for you. Thank you. Thanks for hearing. Assalamu alaikum.